Hello, I'm Saif Ahmed and I'm going to solve this problem of Newton's law of cooling, which is at the instant that a cake is removed from the oven, the temperature of the cake is 350 degrees. After 10 minutes, the cake's temperature is 200 degrees. If the temperature of the room is 70 degrees, how much longer will it take for the cake to cool to 90 degrees? We know that the initial temperature is 350 degrees, and after 10 minutes it's 200, and the room of the temperature is 70. We need to know the time it takes to reach 90 degrees. Okay. The Newton's law of cooling says that T minus T surrounding equals T initial minus T surrounding times e to the power kt. Let's use our values here. T minus 70 equals 350 minus 70 e to the power kt, which gives us T minus 70 equals 280 e to the power kt. Now we need to find the k. We are going to use this value. At the time 10, the temperature is 200. So 200 minus 70 equals 280 times e to the power k times 10. Let's find the k now. Here we'll get 130 divided by 280 equals e to the power 10k. Let's use ln here and ln here. We'll get 10k equals ln 130 over 280, and k equals ln 130 over 280 divided by 10, which is equal to, use the calculator, so this will be our value, negative 0.0767, as we can see from the calculator. Now after finding k, let's write the equation again. T minus 70 equals 280 e to the power negative 0.0767 t. Now to find the time it reaches 90, we'll use 90 here to find the t. So let's do it. 90 minus 70 equals 280 e to the power negative 0.0767 t. 90 minus 70 is 20 divided by 280 equals e to the power negative 0.0767 t. We'll use ln here and ln here. We'll get negative 0.0767 t equals ln of 2 over 28. We'll divide this here and here. We'll get t equals ln of 2 over 28 divided by negative 0.0767, which is equal to, as we can see here from the calculator, 34.408. This is the time it takes to reach 90 degrees. But we want to know how much longer will it take after the 10 minutes. So we minus 10, 34.408 minus 10 equals 24.408. So it will take approximately 24.408 minutes to reach 90 degrees.
Newton's law of cooling. Newton's law of cooling is an application of differential equations for exponential growth and decay and in this case it will be decay because it is law of cooling. Newton's law of cooling has its own formula. We will use this formula to solve this question, or this example about the law of cooling. The example says a cup of coffee was made at a temperature of 90 degrees and cools according to Newton's law of cooling. The room temperature is 30. If the temperature of the coffee 20 minutes after being made was 40 degrees, what is the temperature of the coffee 10 minutes after being made? First of all, we must write the formula of the Newton's law of cooling, which is here, which is T of T is equal to the surrounding temperature plus the initial temperature of the coffee minus the surrounding temperature, which is the room temperature, times e to the power of kt, with k being the rate of cooling, which must be negative, and t being time, in this case in minutes. After writing the formula, we must substitute the numbers. So T of T would be equal to the surrounding temperature, which is 30 in this case, and the initial temperature minus the surrounding would be 90 minus 30, which will give us 60 and e to the power of kt. We don't know k nor we know t till now. The third step is to find k, and we can find k by substituting T of T by T of 20 and time by 20 minutes, and this way by substituting the numbers we can find k in this way. The last step is by after finding k, we substitute the k and we find T of 10. So we substitute T by 10, and here we can find that the final temperature is 54.49 or almost 54.5.
Okay, we come back now by Newton's law of cooling. Okay, we know that the equation of Newton's law is T. Okay, focus here. Okay, of T small minus Ts of that the surrounding equal T initial minus T surrounding again EKT. Okay, this is the equation. Now we have an question that talk about the Newton's law of cooling. It's saying a dish of a cake baked at 350 Fahrenheit is taken out of the oven into a kitchen that it is 71 Fahrenheit. After 8 minutes, the temperature of the cake is 281.9 Fahrenheit. When will the temperature be 225 Fahrenheit? Around your answer 10 years time. Okay, now we know that the cake the first after 8 minutes the cake temperature will be here, you write here 281.9 minus 71, that is the kitchen temperature, and here we have the initial temperature at 350 minus 70 again, and here E we have to get the K, and here it's 8 minutes. Okay, after calculating we will get here, okay, we get here to 1 yes, and here we'll get 279. Here E8k. Okay, and here we have to divide 279. Okay, here EK equal will be the answer here 0.72043. There's too many numbers. We do learn for both sides. Okay, here we'll cancel 8k equal negative 0.3279 and too many numbers. Here divide by 8. Here will be k equal negative 0.04 here 0988 and also many numbers. Okay, here we find the k. Then now he want the time that will the cake will be at 225 Fahrenheit. Okay, 1 second on you. Okay, here we say that he wanted at 225 171 again, and here we have equal 350 minus 70. Okay, here we say that it is 0.040988 t. Okay, here after calculating we'll get 454 equal 279. We know that negative 0.040988 t. So here we'll divide, here we will get, after calculating the t, we will get it that it is t equals 16.023 minutes. And there it is, Newton's law of cooling.
Hello everyone, I will be speaking today about Newton's law of cooling, and I have two questions. This is the first question. As we know, there is an equation or a law called Newton's law of cooling. We get this law from solving the differential equation dt over dt equals to t initial minus t of the surrounding times k. After solving this differential equation, we will get the equation of t of t equals to ts, which is t surrounding, plus t initial minus t surrounding e to the power of kt. This equation is found after solving this differential equation. There is a video of my colleague solving this differential equation, to get this equation. First, we need to solve this equation. To find, we can use this equation to solve any Newton's law of cooling question. First of all, let's read the question. An apple pie comes out of the oven at 425 Fahrenheit. As it's seen that the T initial, which is TO, equals to 425 Fahrenheit. Then placed on a container in a 68 room to cool, which is the surrounding 68 Fahrenheit. It has cooled to 190 after in 30 minutes. It has cooled to 195 Fahrenheit. For according to Newton's law of cooling, how many additional minutes must pass before it cools to 100 Fahrenheit? First thing we should do is to find the K. We have the initial, we have the surrounding, and we have in 30 minutes how much is the temperature. So what we are going to do, we are going to substitute these values in the equation to get K first. So T of T, which is T at 30 minutes, is equal to 195 equals to the surrounding 68 plus 425 minus 68 e to the power of 30 times k, which is 30 minutes. It's now 95. 195 get 68 to the other side. 425 minus 68, which is 325 e to the power of 30k. 195 minus 68 over 325 minus 68 over 325 equals to e to the power of 30k. We get solving this, it gave us to get rid of the E, do ln of 125 over 325, and here ln, which ln of here and ln of here would cancel this ln with the E, making it 30k. Dividing by 30 on both sides will give us k equals to ln 125 over 325 equals to 0.0344. This is the key. Now this is the first part of the question. How many additional minutes must pass before it equals to 100 Fahrenheit? So we want to know how the time the minutes that it needs to cool and when it's 100 Fahrenheit. So what we are going to do, we are going to use the same equation, T of T equals to Ts plus T initial minus Ts e to the power of kt. Okay, we have, as in the question shows, 100, so 100 minus 68, the same thing, 325 e to the power of, we got the k, which is 0.0344 t. We need to solve for t this time, so 100 minus 68 divided by 325 equals to e 0.034 t. Then we get ln in both sides to cancel the exponent, so ln 32 over 357 equals to, then cancels with ln, then cancels with exponent, so 0.034 t. Then t, solve for t, divide 0.034 by the length 32 of over 357, we get us t equals to 70.1 minutes. This is the second part of the question. Now it's saying how many additional minutes must pass before it equals to 100 Fahrenheit. So delta t, or we should find the difference in time, which is, it would be t minus 30 equals to 70. So t equals to 70. I had some mistake here. We should subtract the 70 minutes from the 30 minutes at the first to see how many the additional minutes that passed before it equals to 100, which is 70 minus 30 equals to 40 minutes. This is the final answer. I hope you understood the question. It's so easy and simple. Here's a last view of the question. If you have any concern, just tell me. Hello again, everyone. This is the second question I was talking about. Let's start from it's about Newton's law of cooling. First of all, we should know that we have a law of Newton's of cooling by solving the differential equation of dt over dt equals to kt initial minus t surrounding. This differential equation, after solving it, will give us t of t equals to t surrounding plus t initial minus t surrounding e to the power of kt. Reading the question, at the instant that the cake is removed from the oven, the temperature of the cake is 350 Fahrenheit. After 10 minutes, the cake's temperature is 200 Fahrenheit. If the temperature of the room is 70, how much longer will it take for the cake to cool to 90? First of all, solving any Newton's law of cooling, we should find the K. At first, we have the T initial, which is 350. The T surrounding is 70 Fahrenheit, and we have the time of at the beginning. We should find the K by this, and the 10 minutes time, and the temperature at this 10 minutes is 200 Fahrenheit. So we can substitute 200 here equals to 70, which is the room temperature, plus 350 minus 70 e to the power of 10, because at 10 minutes it's 200 as shown. 10 times K. We subtract 200 minus 70 equals to 350 minus it's 280 e to the power of 10k. 130 280 e to the power of 10k. Take 280 to this other side by dividing it. 280 equals to e to the power of 10k. To cancel the exponents, we take the ln of both, ln and ln. E will cancel with ln, so ln 130 over 280 equals to 10k. Taking k to 10 to the other side to find k equals to ln 130 over 280 divided by 10. K is negative 0.0767. This is the first part of solving the question. Then it shows that if the temperature, how much longer will it take for the cake to cool to 90. So you should find the time to get 90 Fahrenheit. Use the same equation, which is T of T equals to Ts plus T initial minus Ts e to the power of kt. We substitute the 90, which is given in the question, minus 70, which is the T of surrounding, equals to 280 e to the power of, we have the k, which is 0.0767 t. We should find the time when the temperature is 90. So 20 divided by 280 gives us e to the power negative 0.767 t. Getting rid of both sides to cancel the exponent, same as the first part of finding k. So to find the t, ln 200 over 280 gives us negative 0.0767 t. Taking the negative 0.767 by dividing it will give us t equals to 34.408 minutes. That's the second part. It shows it needs how much longer will it take for the cake to cool. So we should find the difference between the time at 200 and 90, the difference between them. At first we get, which is at 10 minutes, and then we got 34.4. So t, the difference is t equals to 34.408 minus 10, which is 24.408 minutes. To cool to 90, it will take 24 minutes to cool to 90 Fahrenheit. I hope you understood the question. If there is any concern, you can tell me. Thank you.
Welcome back to part 3, which is Newton's law of cooling, which is question 14 from systematic quiz 2. Let me read the question. At the instant a cake is removed from the oven, the temperature of the cake is 350 Fahrenheit. After 10 minutes, the cake's temperature is 200 Fahrenheit. If the room's temperature is 70 Fahrenheit, how much longer will the cake take to cool down to 90 Fahrenheit? Sorry. Yeah, okay. So, first we should know the equation, both equations for the Newton's law of cooling, which is T minus Ts, which is T surrounding, equal to T naught, which is T initial minus T surrounding, EKT. And also we have another equation, which is T of T, which is the main one, T initial minus T surrounding, e power KT, plus the T surrounding. First, let's classify the variables here so it's easier for us to find what is needed. They want T, which is this one, for a specific time, but we don't have K. So the first step is to find K, which is the main, so we can find the main equation, and then we substitute substitute every variable to find the T at specific heat, which is 90 Fahrenheit. So let's start with classifying the variables. What is 350 Fahrenheit? It's the initial, when the cake is removed, which is 350 Fahrenheit. Great. Okay, and then what is the 200? 200 is the temperature, which is T. So T is equal to 200 Fahrenheit. What is T surrounding? They've said that if the room temperature is 70 Fahrenheit, so 70 Fahrenheit. And they gave us a time which is 10 minutes at the beginning. The time they give us at the beginning will help us to find the key. So the first thing we should find, step 1, find K. Step 1, find K by substituting simply 200 minus T surrounding 70 equal to T initial, which is 350 minus 70 times e power K at the time 10, because they gave us the temperature at time 10 is 200, but we want to find the time at the temperature is 90, but we need K. So K will be equal to, so here 10 200 minus 70 divided by 350 minus 70, then ln, which is K10, it's ln of all of this, which is 200 minus 70 divided by 350 minus 70, and then again divide by 10 all of this. So you cancel it from here. The value of K will be minus 0.0767. Of course, it will become negative because it's cooling, so it's decreasing in temperature, so it will become the constant will be negative. So let's use the equation, which is this one, the constant equation, T of T, which is at any specific temperature, T initial minus T surrounding e power kt plus T surrounding. Simply substitute the numbers, which is, so now the temperature they want us to find is 90. So 90 is equal to T initial 350 minus 70 times e power K, we know, sorry, here's 0 again, times T, the time that we want to find, plus TS. Oh, sorry, TS is also 70. So e power minus 0.0767 T is equal to 90 minus 70 divided by 350 minus 70. We take also ln, let's do it from here, and then after doing the ln, e will be cancelled, so T will be equal to ln of 90 minus 70 divided by sorry, the paper here, 350 minus 70 ln of all divided by minus 0.0767. So T will become 34.408. But this is not the temperature. This will be at 90. At 90, excluding the 10 minutes that was decreased when it became 200 Fahrenheit. So the T is minus 10, which is 24.408 minutes. This is the only question for Newton's law of cooling.
I will solve question 14 from system-wide quiz paper, which is about Newton's law of cooling. So I will read it out before solving it. The question says, at the instant that a cake is removed from the oven, the temperature of the cake is 350 Fahrenheit. After 10 minutes, the cake temperature is 200 Fahrenheit. If the temperature of the room is 70 Fahrenheit, how much longer will it take for the cake to cool to 90 Fahrenheit? So, first we will use the formula T minus T surrounding equal to T naught minus T surrounding times e to the power of kt. T is 200 minus 70 equal to 350 minus 70 times e. K is unknown, so we are working on finding out K times T. T is 10 minutes, so it will be 130 equal to 280 e to the power of 10k. E to the power of 10k is equal to 130 over 280, and then it will be 10k is equal to ln 130 over 280 over 10, so 10 to cancel. So k, it will be equal to minus 0.0767. Then we will work on finding t for when will it take to be, how long will it take it to be 90 Fahrenheit. So to be 90 minus 70 equal to 350 minus 70 e to the power minus 0.0767 t 20 equal to 280 e to the power negative 0.0767 t, and then t will be equal to be equal to ln 20 over 280 over negative 0.0767, which will be equal to 34.408. Then we will minus this, we will take this and minus it to 10 minutes. 34.40 minus 10 give us 24.408 minutes. So it will take 24.408 minutes to cool to 90 Fahrenheit. Thank you.
Another objective, Newton's law of cooling, question 14 from the system-wide quiz paper. The main equation is T minus T surrounding equals to TO minus T surrounding e to the power of KT. Then we just substitute the numbers given to us in the question. 200 minus 70 equals to 350 minus 70 e to the power of 10k. Then we just need to solve for k as shown here. 200 minus 70 equals to the same as here the equation. Then we just
calculated. 130 equals to 80. Then to find k, it's going to be ln. We multiply both sides by ln to cancel the exponential function. Ln 130 over 280 over 10 equals to k. Then we end up by having negative 0.767. We do it again by substituting the values in the equation, in the main equation as given here, but with the new values. 90 minus 70 equals 280 e to the power of negative 0.767, which is k as we found here. Then t equals to ln 1 over 14 over negative 0.767, which equals to 34.408.